Okay, guys. So as I was saying, we will continue with the triangle properties today. So that is what we want to continue. We want to do a quick revision of what they are, and then we'll move on into an activity, and then we will work with the six problems that I had asked you guys to write down, to draw them, and then write down in your question in your notebooks. So now, yesterday, as you were talking about the different types of triangles, we talked about six different triangles that are classified. You have three of them classified by side, and you have three of them that are classified by angle. When you have a triangle that is so now you have six types of triangles, right? You have scalene, you have the isosceles, and you have the equilateral. Now, if we talk about the equilateral, all the sides are the same and all the angles are the same. And we had said yesterday that all the angles have to be 60 because 60, 60, and 60 would give me the 180 that is requested of me. The isosceles triangle would have two sides that are the same, and then you would have, for example, if I move something in the isosceles, two sides have to be the same. All right, two sides have to be identical. So this side and this side are identical, and because two sides are the same, you would have two angles being the same as well, right? And however it is that your isosceles would look like, two angles will always be the same and two sides will always be the same. Talking about and scalene now. In the scalene, it does not really matter because all sides are different and all angles are different. So I have three different sides measuring different lengths, and I have three different angles inside. So this is what the scalene basically is. So those are when you classify them by side, right? Now, when you are classifying them by angle, you always have one that is a right angle triangle, has a right angle in it. So for a triangle to be right angle, it has to have 190 degrees, and then the other two, it could be whatever magnitude the other two want to be. For the acute, everything in the acute has to be smaller than 90 degrees. All of the three angles have to be less than 90 degrees. None of them could be 90 or could be more than 90 because it no longer will be an acute. And then when we talk about an obtuse, we have one triangle that is um, bigger, not one triangle, one angle that is bigger than 90 degrees, for example 91, and this one angle determines that that is an obtuse angle. All right, so those are the six triangles that we talked about yesterday, three of them by side and three of them by angle. All right, so now we then talked about the theorems. We talked about four theorems that we would like to learn, basically, to learn and to be able to recall, not really memorize. We want to recall them so that we can apply them. The first theorem stated that three angles in a triangle have to add up to how much degrees? How much degrees does a triangle have to add up to? 180. Very good. 180. Now, 180 adds up to a straight line, right? So, I have three angles and all of them must add up to 180. And I could remove and reshape my triangle in a whatever different form, but always will my three angles inside of the triangle always equal to 180 degrees. All right, so however it is that my triangle looks like, I will always need it to add to 180 degrees. So that is the first theorem that is there. Moving on to the second theorem. Let's say that I have this triangle. What this is saying, this theorem number 2 is saying, is that if I have a really small angle, let's say that this is the smallest angle, then this side, the side that is opposite to it, is going to be the shortest side. If I have a really big angle, then the side opposite to it is going to be the longest side. Now, how does this theorem help us? Well, it's basically for us just to cross check if our answers are correct. If you are to find the length of a side and you get that one side is 15, but that is supposed to be the smallest side, but you get the biggest number, then you know that your answer is not correct. And this theorem has two parts to it. And basically, part A and part B are saying the opposite. One part says that if the angle is small, then the side opposite is going to be small. If the angle is big, the side opposite to it is going to be longer. The other part says the opposite. It says that if I have a really short side, the angle opposite to it is going to be really tiny. And if I have a really long side, like this one, the angle opposite to it is going to be really big. Right? So then this is what it is saying. And let me make it bigger for you. Right? So this is what it is saying. If I have a really small side, like this side is small, then the angle opposite to it is going to be a tiny angle. But if I have a really long side, the angle opposite to it is going to be a really big angle, right? And that is what it's saying. So that is theorem number 2. Anybody has questions with theorem number 2? And I think that one was the one that had a lot of words, very difficult to comprehend because of the wording. Now, the other two theorems talk about exterior angles. So theorem number 1 and theorem number 2 talk about interior, talk about the inside. And theorem number 3 and theorem number 4 talk about the outside. Right? So talking about exterior angles. Let me do exterior angles. Exterior angles are angles that are formed by one side of the triangle and an extended side. So this is what we call the exterior angles, the one in gray, the one in green, and the one in red. Now, theorem number 3 says that if I want to calculate this one in green, I will go to the angles inside of the triangle and I will add this one and I will add this one to it. Because adding the two opposite gives me the exterior. If I want to find out what the red one is, I will add this one and I will add this one, and that will give me the red one. If I want to calculate the gray one, then I will calculate this one and this one and add them, and that will give me the gray one. Right? So then that is what the third theorem states. The last theorem talks about exterior angles as well. All right? So now what does it say about exterior angles? It says that the three angles on the outside have to add up to how much? Anybody knows? 360. To 360. Very good. So they have to add up to 360. So if my triangle looks like this, they're supposed to add up to 360. And 360 is the magnitude of a circle. And if I were to reshape my triangle, however way my triangle would have looked like, they always have to add up to 360. It does not matter the shape of my triangle, but they all have to always add up to 360. Always. Right? No matter how my triangle looks like, all of the exterior angles must always add up to 360. And those are the four theorems that we have for a triangle. Is it more clear right now? The four theorems. Okay. Okay, good. Now, what I want to clarify, what is an exterior angle and what is an interior angle? And this diagram helps us understand that. All of the angles that are on the inside of the triangle, so the little ones that you see in blue, are interior. Those are on the inside, and we only have three interior angles. Exterior angles are a little bit more difficult to understand. We have 6 different exterior angles. But what does that mean? If I use this one to be an exterior angle, if I am using this one right here to be an exterior angle, I cannot use the one at the top. It's only either or. So one corner of a triangle can only have this one or this one. It cannot be both, and you cannot use both of them. If I look at this one at the top, it is either the one on the right or the one on the left. It cannot be both of them. And the same thing with the last one. So it's either or. The angle in between, so if I were to extend this line and I extend this line, what is in the middle is not an exterior angle. It is not. So we have to be careful, and this is very important when we are looking at the triangles and when we have extended our triangle sides. So let's look at some questions very quickly, and then we will move into the activity, the questions that are in the package. All right. So we can go very quickly doing this one. I'm on level 1. Maybe you should go to level 2. Let me see. Now, let's work with level 1. And then we will just answer the questions very quickly. And then we will move to the work that is in the package. Right? Can you guys see this, or do you want me to zoom a little bit more? Can everybody see it clearly?
Yes.
Yes? Okay, good. So we have one triangle that has one angle being 30, one angle being 70, and we have to find the other angle. How would we do that? What would you do in this case? Anybody? What would you do so that you can find the other angle? Add? What would we add?
This 30 and the 70.
Okay, I would add the 30 and the 70. If I add 30 and 70, that gives me 100 degrees. Then is 100 degrees my answer?
No. You need to subtract.
Then I would need to subtract the 100 from what?
180.
Okay, very good. So when we are talking about these kinds of problems, we have to be thinking, we have to analyze the problem first, and then we want to think about what it is that we're going to be doing. The first thing that I want to do is that I want to have 70 plus 30. And that is going to give me 100. Once I have that 100, I'm going to take the total degrees in a triangle and I'm going to subtract it from whatever it is that I got from the addition. And my answer is going to be that difference. Any questions? Did everybody understand that?
Yes, yes. Yes, ma'am. Yes, yes.
Okay. The second one. And we can do this very quickly, right? 81, 26, and B, and you have to find angle B. And we're going to do the same procedure. I'm going to take 21 and I'm going to add it, 81, sorry, and I'm going to add it to 26. And how much would that give you?
110.
107. Very good. Then I would take 180 minus 107, and how much would that give you?
73.
73. Very good. 73. And that would be your answer. Let's look at one like this one right here. I have one angle being 51, and I have to find E. But it is important to note, let me see if I can zoom this. It is important to note that this triangle has two bars on two lines. What do those bars on those lines represent?
The sides are equal.
It is a isosceles triangle and both sides are equal. And because both sides are equal, what does that say about the angles?
The angles are equal to.
The angles are equal to. Very good. So now, yes.
Like if it is an outside isosceles triangle is like every angle is 51 degrees from it.
Okay, in this case, because it is an isosceles, it means that two angles are the same. The two angles at the bottom and the two angles that are opposite to each other. So in this case, it would be this one because it is from this line, and this one because it is from this line. Two of them are the same size, so by consequence, two of them are going to be the same magnitude. So what I'm going to be doing here is I'm going to add 51 twice, or I could do 51 times 2, whichever one, and this is going to give me 102. Now for me to find angle E, then now I'm going to do the 180 minus the 102. And what would that give you?
78.
78. Very good. 78. Right? So I have to be able to see these things. Understand that if it has the lines have the little bars on them, it means those sides are equal. And because those sides are equal, it means that the angles are also equal. All right. Now let's look at this one. This one is the opposite. In this one, they give me an angle at the bottom and I have to find the other one. In this one, they give me the angle at the top and I have to find the bottom one. But I need to also see that this line and this line are the same. And because they are the same, it means that this angle F is going to be the same thing as this angle over here. Does everybody see that?
Yes, miss. Yes, miss. Yes.
Good. So now what am I going to do here now? Because I can't do the same thing. What do I need to do first now?
Subtracting
What will I subtract?
52 minus 180 and
Okay, I am going to take 180 and I'm going to subtract 52 from it. What is that going to give me?
what? 128.
128. Very good. What am I going to do now? Because the 128 is for the two of them that are missing, right? The two of them that I do not know. But I do know that but the two of them are the same thing. So what would I do in this case? Okay, I think that I got kicked out a little while. I'm not sure if you guys heard what I said. We have found out that it is 180 minus 52 and that gives me 128, right? Now that 128 is for the two angles that I do not know. It is for the two at the bottom. But I know that the two at the bottom are the same thing. They are identical to each other. So if both of them together measure 128, what am I going to do so that I can find for only one?
My said can't hear you clearly.
I'm sorry about that. I think that it is my internet because I am looking at your cameras. They are blinking, some of you, and I can see. I'm looking at myself on my other device, and I can see that it's broken. So I'm sorry if, but it's my internet that is giving a lot of problems.
Miss, my internet is also not working well.
The recording will be
Yes, this
available,
is
guys. So if you guys don't hear me clearly, no problem. You can look at the recording, right? But we want to get this through. In this case, I did see Edmond put it in the chat. Very good, Edmond. We will do 128 divided by 2. And then that is going to give me how much?
64.
64. Very good. 64. Now, why did I divide it by 2? Because because both
If
of
two sides
them,
are equal,
very good. Both of them are equal. Very good. So this one would be the same. Let's look at this one. This one is a little different as well. I have 27 degrees. This is a right angle triangle, and I'm looking for the magnitude of angle H. What would I do in this case? Who can tell me?
the 93.
I am going to take the 27 degrees. That is one magnitude. I'm going to take the right angle, and the right angle I know measures 90 degrees. And I'm going to add both of them. And this is going to give me 117. Now, for me to find the magnitude of H, what am I going to be doing with that 117?
Subtract from A180.
Subtract it from 180. Very good. And when I do that subtraction, what do I get?
63. 63.
63. Very good. 63. And that will be my answer. Everybody is getting the idea of what is happening here.
Yes, yes, yes.
Let's do this last one, and then we will move on to the 6 questions that I have for you guys. You know what? No, let's not do this one. I will do this one with you guys tomorrow, right? Because I'm looking at the time, and I want us to do the questions that are in the package. So let me share my screen from here. Okay. Right there. This is the first question, right? You guys are supposed to already have it. You guys are supposed to already have it drawn in your notebook. Let's look at the question. And they are asking you to find the magnitude of angle U. So they're telling you for this one, right? So now what you guys are going to be showing me is when you take pictures of your work, I want to see the drawing, I want to see this triangle, I want to see your working, and then I want to see your final answer. That is what I want you guys to take a picture of, right? So this one is very direct. What do we have to do in this case? Who can tell me very quickly, and then I will be doing the working.
63 plus 37 degrees.
Very good. That would be the first step. I would have 37 degrees plus 63 degrees. And I'm looking for... Okay, let me redo that. Show you guys how to do the working. I'm looking for the magnitude of angle U. So now the first step is that I'm going to take the 37 degrees and I'm going to add it to 63 degrees. And what is that going to give you?
100.
100. Very good. What will be the second step?
180 minus 100 is
180 minus 100. Very good. And that gives you 80 degrees. So my answer here is going to be 80 degrees. Degrees. Right? Any questions? Is everybody writing?
yes, miss, yes.
Very good.
Miss, clear, clear, clear. Miss. No, miss, no,
Good.
miss.
Not yet. Not yet. Okay. There you go.
No, miss, no. Don't.
Okay, good. Let's move on to the other one. Number 2 has 46 degrees being angle A. You have a right angle at angle C, and then we are looking for the magnitude of angle B. Right? So this one we're looking for. What am I going to be doing here in this case?
46 degrees plus 90 degrees.
Very good. 46 degrees plus 90 degrees. What does that give you?
136.
136. Excellent. And now I want to find the missing angle, so I'm going to subtract that 136 from 180, and that gives you how much?
44.
44. Very good. And my answer is going to be 44 degrees. Let me know when I can move on.
Don't miss.
Finish? Okay. Number 3. Number 3 has 36, 51, and then we're looking at angle Q. Right? You don't bathe?
My tooth.
Wow, okay. Okay, so we're gonna talk about 36 degrees and then we're gonna add it to 51 degrees, right? Because those are the two that they give us. How much would that give you when you do the addition?
87.
87 degrees, very good. And then what do I need to do?
180 minus 87.
180 minus 87, very good. And the answer would be
93.
93 degrees. And my answer here, 93 degrees. Can I move on? Yes.
Yes, miss. Yes, yes, done.
So now this one, well, the first 3 questions talked about the interior angles, right? But the following 3 questions talk about exterior angles, and you're looking for exterior angles. Now, In this case, we're going to use the third theorem. And the third theorem says that if I am looking for an exterior angle, for example, I'm looking at 4x over there, um, I need to add the two opposite interior angles. And what are the opposite interior angles? These ones, because they're directly opposite to it. Right? So the theorem says it is equal to the sum of the opposite interior angles. So for a question like this, I am going to take the 49 degrees and I'm going to add it to 80 degrees. How much would that give you?
129.
129. And that would be your answer. Did everybody understand?
Yes, ma'am. Yes, yes, yes.
Very good. Can I move on?
Yes, ma'am. Yes.
In this one, I'm looking for VUX. So I'm looking for this angle right there, which is the exterior angle. So what would I do for this question?
You got a different question. What?
You have a different question?
One, 102 plus 53.
This is the question you have in your package, right? Or did I copy the wrong question?
You got not next question.
You got another question? I'm not understanding.
No, miss, that's the one you gave us.
Okay.
Miss, I have the one.
You have the same one? Okay, because or Joshua, I didn't really understand what you said if because it's broken up when you unmute. So if you have a question, then you can put it in the chat, okay? So now what I'm gonna be doing in this case is that I'm gonna add the opposite interior angles, both of them. So I'm gonna take the 103, I'm gonna add it to 53, and what is that gonna give you?
106.
156. Very good. 156 degrees. Yes?
Yes.
Good. And then the last one.
Wait, miss, no acaba de. Ya, miss. Same thing, miss.
Let me know when you're finished copying.
Finish.
Okay. And the
Miss,
last
that is all
one.
the work?
Yes, that is all the working. That's all you have to do for the question. The last two question ask for angle HFX. So they're looking for this angle over here. And because I'm looking for an exterior angle, I will add the interior opposite angles, which are these two. So I'm going to take 39 degrees and I'm going to add it to 26. What would that give you?
65.
65. 65 degrees. Yes? Okay.
Yes, yes. Yes, miss.
Okay, so for tomorrow, I would like that you guys have the other 6 questions in your are drawn already, because tomorrow we will be talking about the quadrilateral properties, and we will be talking about the polygon properties, right? So you can go ahead and have those illustrated in your notebook right behind these ones that we did right now. So you have 6 more problems, and then we are going to talk about those ones tomorrow. I'm also going to explain the first activity. I'm not sure if everybody has understood what they need to do for the first activity, but I will not be doing that with you guys because it's not really it doesn't call for you to do any mathematical calculation. It's just an activity that is related to our biblical framework and the one that I'm talking about in the unit. But I will explain that in detail what it is I have to do. I did also do a recording yesterday and I posted it that talks about explaining the assignments, right? I know that it's time and you have another class. So then tomorrow, please have the other 6 questions drawn. Be ready for tomorrow's class because I want to go a little bit faster tomorrow because I want to cover all of the other properties that are left. So that will be it for today, guys. Have a great rest of the day. Enjoy your day, and I will be seeing you guys tomorrow.
Bye, miss. Bye.
Bye.
Bye, miss. Bye, miss. Bye, miss.
Goodbye.
Bye, miss.
Bye.
Miss.
Yes.